This screencast is for the stacks of graphs in our packet there, starting with page 14. So looking at this, where we have seen this simulation before where we can have this ball get rolled with a constant velocity. We see how this position graph reacts. We can have it go with a negative velocity in a different direction. Negative velocity means it moves in a different direction, still a constant velocity. We can see how this velocity graph behaves with a constant velocity. It has a constant negative value, and there's a zero acceleration. We can then have this ball go in the positive direction still with a zero acceleration. The velocity is just a constant positive, and we see how the velocity behaves, where it's a constant increase in this position with respect to time. So with the velocity being constant, we see the position graph being this linear relationship. Now if we have a acceleration to this, that's where we have a ramp here. We can have this ball start from point 0. We can see what happens to the position graph. We see the position graph, it now changes, going from a constant slope to where the slope is increasing over time. So since that slope is increasing, we can see then our velocity here increases. Velocity is the slope of our position versus time. And this velocity graph has a constant slope, so then our acceleration graph should be a constant positive value. So we're going to take this and we're going to apply it to page 14 in our packet. So let me take us there. So this is the page 14. So I'm referring to the bottom of the page here where it says the number 14. So this is the bottom of the page. So this is what we're using. This is what we're doing. So as we look at number 1, we have an object that increases its position and then turns around and starts going in the negative direction. So we see that this first object goes in the positive direction for some time, and then it goes in the negative direction more on the back end. So this here has a positive slope. So that's why we have a positive here. This is a negative slope. That's why this is a negative value down here. I tried to make this one more negative than this one is positive because this is positive, but this is a more negative slope. It goes a farther distance over time. It has a bigger negative displacement here with respect to time. So it has a bigger negative velocity. Now, this has a zero slope, and this also has a zero slope. So since the velocity does not change, the acceleration is a constant value for all time. As we do this, I don't want us stressing about this part here, but I do want us getting to the description here. So in this description, we can say that the object starts at a positive initial position, moves in positive direction, with a constant velocity, then moves in the negative direction with a constant negative velocity. So that way we are fully describing exactly what's happening there. So this is the positive constant velocity, a negative constant velocity, and we see that it's a constant positive and a constant negative. This is saying right here for its positive initial position. So this is the positive x sub 0, that positive initial position. Then as we look here to number 2, we're going to apply the same principle here, where this slope right here is a 0 slope. The slope at the end is a positive slope. So 0 in the beginning. This is getting positive. This is more positive. So our velocity starts at 0. Then it's more positive and more positive. So what we're seeing here is our velocity increase over time. And we see it increase at a steady rate. And since our velocity is increasing at a steady rate, we see that the velocity increases. So there is a positive slope here. So it increases. This positive slope says that our acceleration is going to be this positive constant. That is given from our velocity graph. And once again, I don't need you doing this part here, but I do want you getting to a description here, where your description can say that the object starts from rest with a positive initial position, and then its velocity increases at a constant rate in the positive direction. Positive initial position. The velocity is increasing, as you can see with the slope here increasing. This slope is increasing, so the velocity is increasing at a steady rate. The rate is that acceleration. As you continue, you get to our page 15. Now you're starting with an object that is starting here with a positive slope, and it goes to a 0 slope. So since it starts off in the positive, you are going to have a positive velocity to start and then a 0 velocity, so it's going to go from high to stopping. So it's going to have a high velocity, and then it stops. So then you need to get the velocity of something that's moving in the positive direction, and then it stops. And in order for the velocity to change like that, there has to be an acceleration. So you need to get that acceleration here. And further, once again, we're not doing this. We're also not doing this. As you look to this next one, it starts here at a constant position. So the velocity is 0 because it's not moving, and then it starts moving in the negative direction. So we need to get to a velocity that is a 0 velocity, and then it begins moving in the negative direction. So we need to show that the velocity increases in the negative direction. And the only way that the velocity changes is that there is an acceleration. So thank you and good luck as you continue with this